in the previous lab in the previous lab today I have discussed the inverse Laplace transform. MATLAB, the use of MATLAB to find out the inverse Laplace transform. In the previous lecture, you have write down the MATLAB code to find out the given signal Laplace transform. The Laplace transform of the standard signals. You have find out the Laplace transform of the sine function, cosine function, sine hyperbolic function, cosine hyperbolic function, exponential function, and there are various types of the signals Laplace transform. You simply write down the Laplace transform of in Laplace transform in the MATLAB. Here, then you have find out the inverse Laplace transform of the given signal. Suppose you have find out the Laplace transform of the function. Suppose x1 is x plus 4 plus s square plus 5s plus 6. This is the given Laplace transform. You have find out the inverse of this. Means you have find out the x1t. You have find out inverse Laplace transform of this given signal. This is x1s, and you have find out the x1t inverse. There are various processes to find out the inverse transform by computing manually or conventionally. In the mathematics class, there are various methods: partial fraction method, power series expansion method, long division method. Partial fraction method is most popular method. Partial fraction and the Cauchy integral. Partial fraction means here you have find out the inverse Laplace transform by using the MATLAB code, and you have the basic steps to find out the inverse Laplace transform of a given signal x1s. The x1s is given as x plus 4 by x square plus 5s plus 6. This is a given function, one type of a given function. Then you have find out the inverse. Here you have write down the comment inverse Laplace transform of x1s. Then xyms, this is a symbolic variable toolbox syntax. Here the s is the suffix to the variable. The nature of this variable is a complex, that's why you have declared this complex. These are the symbolic toolbox notation you have declared. Then x1 is equal to x plus 4 divided by x square plus 5s plus 6. This is the notation to write down the script in the MATLAB. Here this is the basic notation. X plus 4, you have written the addition operators. Then this is the division operators can be written in this form, and then x square, this can be also written in x cap plus 5s plus 6. Then this is the function, given function. Then display this inverse Laplace transform of this given function. This is a basic command to display this function. And then this is the built-in command I suffix inverse I. You have Laplace transform with the basic command. Here you have suffix I Laplace. I means inverse Laplace transform. Simply you have in mathematics, you have find out the x1t. Then this can be also L inverse x1s. Okay. Yeah, you have given I and V. Then simply you have I Laplace of x1. This is the built-in command to find out the inverse Laplace transform. And then you have x1. This is a typos error. Yes, small x. You have x1 is simplify this complex terms can be simplified by the simple command simplify, and then then this is comment as display the Laplace transform of given function, inverse Laplace transform of given function. Simply you have written x. Simple here this is a small s. And then you run it this function. Yes, simply you have cleared the window. This is some syntax error. Here the syntax error is written this function sym x s plus 4 x square 5s plus 6 and I Laplace the syntax x1. Then you have here the syntax s is capital, here missing small. You have taken the small s. The syntax error in the command window. The x1 here, this is the capital S. You have typed the small s. यहाँ पे सिस्टम CLC. Cross check your code. The comment script is hidden. Comment editor window is hidden. Copy paste. Simply you have declare the ms simple small s. Instead of capital S, you have written the small s, and then you have written the complex function COMLX. Then you have written the s square s. Then you have written the x1 this Laplace display. You have find the x1 x1 ILA Laplace no? Then you have written the x1 equal to simplify the spelling of simplify.
Can run back. SI.
SI.
Cooper.
Yes, I am P L F Y. Yes. Correct it. No. Take. This is the output result of this function. This is the inverse Laplace transform of this given function. Here this is a typos error. This is the inverse Laplace transform of this function. You have also checked by manually by using the partial fraction expansion method to cross check this result. This is the exp exponential means exponential minus 3t into 2 exp minus 1. This is the output of this given inverse Laplace transform. This is the standard result. You have cross-checked the value by finding by the conventional approach to check this answer is correct or not. Okay? This is the inverse Laplace transform by using the MATLAB command directly. This is a simple example. Simply you have 3-line code. Simply you have written the function notation, then you have written the Laplace transform function, given function, then you have converted, then you have find the inverse Laplace transform by a built-in command, and here this simplify function, here this is syntax error, simply, so this is the right code, then the result is displayed. This is a 3-line code. Simply first line you have declare the symbolic toolbox declaration. Here this is the first. Simply you have write down SYMS symbolic toolbox notations and simply SYMS S, and you have declared the complex. These are the declaration of the symbolic toolbox. Symbolic toolbox, this is the notation then you have used in this command. Because the symbolic toolbox is a built-in function, library function, you have arithmetical operations are then like Laplace transform, Fourier transform, there are various operators are built in this library function. This in the MATLAB library, that's why you declare this SYMS. You have not declared this, then you have error in your program. Not find, not define. What did you mean? This types of error in your command window. That's why there is one way up to writing a program. There are various ways to write the program. It's the simplest way to write the program in using built-in function. Because this is a simple program, simple problem to solve, this is the simplest way to write the program. To use the built-in functions in MATLAB library, they have called the built-in functions and simply you have used and find out the output. There are various ways to write the program in using the user-defined functions, right? A bigger program, but the main motive to find out the inverse Laplace transform. This is simplest problem. The large problem you have defined, you have write the code for real time problems. There is no function in MATLAB, then you have defined user defined function. User defined function in the MATLAB, then this user defined function can be used for this function various real time problems. रियल टाइम प्रॉब्लम्स के लिए आपको जैसे कि मैटलैब में जो आपके फंक्शन नहीं है तो हम उसके लिए कुछ जैसे रियल प्रॉब्लम को अगर हम एड्रेस कर रहे हैं तो हमें अपने फंक्शन बनाने पड़ेंगे. यू हैव बिल्ट इन, देन यू हैव फैसिलिटी टू बिल्ड user defined function in the MATLAB. MATLAB is the scientific tool to use for the scientific and research purpose. That's why their area is wide. So MATLAB have various applications in various fields. The MATLAB is used for the mathematician, MATLAB is used for the scientist, MATLAB is used for the researchers. In various fields, you have used the bioinformatics engineers, computer science engineers, use MATLAB in the coding purpose. AI, there is a hottest applications, automations and animations. There are various 3D views to build an mathematical building blocks of any problem. Then you have simulate it. तो आपके जैसे आपके कंट्रोल सिस्टम्स में आपके जैसे कोई भी रॉकेट डिजाइन है या मैथमेटिकल डिजाइन है तो उसका आप सिमुलेशंस मैथमेटिकल मॉडल डिजाइन करेंगे. देन यू हैव सिमुलेट द फंक्शंस एंड यू हैव फैब्रिकेट या implement the design for the hardware purpose. Then check the performance. Then you have for the ready to fabricate in the industry. तो पहले आप प्रोटोटाइप टेस्टिंग करते हैं, उनके आप डिजाइन प्रोस्पेक्टिव्स को, उनके वर्किंग फंक्शन को कि ये जो हमने डिजाइन बनाया है वो फिजिबल है कि नहीं है. तो ये तो इट इज द बिगिनिंग प्रोसेस to write a MATLAB code for the various transforms. This is the simplest way to write a MATLAB code in given signals. This is the one type of application. There are various types of application in signal processing, communication, wireless, control system, and machine learning. There are various tools also available in the MATLAB. There is one more recent tools, deep learning toolbox. This is a part of the artificial intelligence. Deep learning is the one type of subset of this artificial intelligence. There are various applications to solve the real type problems. This is the simplest way to write MATLAB code. This is the one type of the given function. There is various inverse function, inverse given Laplace transform, then you find out the inverse Laplace transform. You have changed the problem, then this polynomial function can be changed, then the result is also changed. To cross check the simplest function, you have write down the another problem. You have checked the s plus 1 instead of x plus 4. The polynomial function is changed. Then you have write the same code for the different problem, different Laplace transform to find out the inverse Laplace transform. Here the problem is changed. You have written x plus 1 divided by numerator is x plus 1 and denominator is x square plus x 1 का square, x plus 2 x plus 1 नहीं, x plus 2. there is slight modification. s plus s square प्लस S1 होल स्क्वायर। ठीक है, दिस इज द वन टाइप ऑफ स्टैंडर्ड S प्लस 2 अपॉन S स्क्वायर इन 2
प्लस प्लस वन
error cross check S square, this type of function, how to find out the inverse Laplace transform। ठीक है, you have find out the inverse Laplace transform of various functions, you have cross check the standard results, then you have find out the inverse Laplace transform of given function। Likewise you have find the 1 upon S plus 1। Suppose there another problem, मान लीजिए x2s इक्वल टू 1 अपॉन s प्लस 1 का लैपलास ट्रांसफॉर्म निकालिए। यू हैव आल्सो नो द रिजल्ट, देन यू क्रॉस चेक द रिजल्ट, योर MATLAB इज डूइंग करेक्ट और नॉट। ये debug your problem, debugging the code means you have cross check the code by step, line by line। MATLAB uses the interpreter, not compiler। One more difference in MATLAB and another programming tools या scientific, जैसे आपका C है, C में आपका कंपाइलर्स है, ठीक है, यहाँ पे आपका MATLAB में कंपाइलर नहीं है। तो कंपाइलर और इंटरप्रेटर का बेसिक डिफरेंस यू हैव आल्सो स्टडी इन द बेसिक प्रोग्रामिंग क्लासेस। तो यू हैव नो द बेसिक डिफरेंस बिटवीन कंपाइलर एंड इंटरप्रेटर, बट द डिफरेंस इज in not a smaller scale, the difference is a larger scale। you have in the वीडियो प्रोसेसिंग या आपके जो लार्ज डेटा सेट हैं, तो वहां पे आप अगर प्रोसेस कर रहे हैं तो वहां पे पता चलेगा। लेकिन MATLAB में देयर आर वेरियस फैसिलिटी टू मैच द वेरियस प्रोग्रामिंग लैंग्वेज कोड्स। MATLAB में आपका अब आपको सी के भी कोड्स को रन किया जा सकता है मैक्स फाइल के थ्रू, आपके जावा के भी। तो आपके वेरियस मतलब सी के कोड हैं, C++ के कोड हैं, उनको भी आप मैक्स कमांड के थ्रू मैक्स उसको इंटरफेस कर सकते हैं। ठीक है, तो आपका एक MATLAB क्या है, एक तरह से कई इन्वायरमेंट को इंटरफेस कर सकते हैं। तो अगर आपको C का बेसिक नॉलेज है तो हम उसको इंटरफेस कर सकते हैं बेसिक रियल टाइप प्रॉब्लम्स को। जैसे आपका कोडिंग अच्छी है तो आप रियल टाइप प्रॉब्लम्स को एड्रेस कर रहे हैं, तो आपको जैसे MATLAB में कुछ चीज़ इंटरफेसिंग की दिक्कत हुई तो हम उसको इसमें मक्स कर सकते हैं, उनके कोड्स को ग्राफिकल यूजर इंटरफेस बना सकते हैं, GUI। ठीक है, तो यूजर फ्रेंडली आपका जैसे आपका एप्स होते हैं, एप्स डिजाइन में भी आपका इंटरफेसिंग आपके कोड्स लिखे जाते हैं कि आपका एक बैक एंड होता है, एक फ्रंट एंड होता है। बैक एंड में आपके कोडिंग रहता है और फ्रंट एंड में आपका वो GUI फॉर्म में बटन्स रहते हैं कि आपके इनपुट दीजिए आउटपुट आपको मिलेगा। ठीक है, एक ब्लैक बॉक्स की तरह, जैसे हम कहते हैं ना कि आपका ब्लॉक डायग्राम हुआ, जैसे लैब में आप क्या करते हैं, वायर कनेक्ट करते हैं, आपका आउटपुट डिस्प्ले होता है। तो इसमें भी आपके कई फीचर्स हैं। सिमलिंग है, सिमलिंग एक इन्वायरमेंट है जिसमें आपके बिल्ट इन ब्लॉक डायग्राम्स हैं डिफरेंट एप्लीकेशंस के लिए, कंट्रोल सिस्टम के लिए या कम्युनिकेशंस के लिए और सिग्नल प्रोसेसिंग के लिए। आप यहाँ पे सिग्नल प्रोसेसिंग टूल बॉक्स का यूज कर रहे हैं, यहाँ पे अभी हम बेसिक सिग्नल प्रोसेसिंग टूल बॉक्स का यूज कर रहे हैं। तो हमने अभी लैप्लास ट्रांसफॉर्म के बेसिक कमांड्स को यूज किया। इसी तरह से हम फोरियर ट्रांसफॉर्म के कमांड्स को यूज करेंगे। तो फोरियर ट्रांसफॉर्म का जो बेसिक कमांड्स है FFT। तो फोरियर ट्रांसफॉर्म आपका इट इज बेस्ड ऑन द फास्ट फोरियर ट्रांसफॉर्म तो FFT is algorithmic approach to find out the given signal Fourier transform। तो आपका FFT एक मेथड है जो एल्गोरिथमिक अप्रोच है जो आपका फोरियर ट्रांसफॉर्म निकालने का। तो यहाँ पे बेसिक कमांड्स हैं, उसके भी बिल्ट इन फंक्शन है, दीज आर स्टैंडर्ड फंक्शन। तो वेल नोन फंक्शंस हैं, तो उनके अब लाइब्रेरी फंक्शन ऑलरेडी एग्जिस्ट करते हैं मैटलैब, ठीक है। तो इसी तरह से आप डिफरेंट प्रॉब्लम्स को जो आपके वेल नोन स्टैंडर्ड फंक्शंस हैं उनको आप क्रॉस चेक कर सकते हैं। जैसे कि हमने प्रॉब्लम दिया 1/s+1 का, सिमिलर स्टेप्स को यूज करके आप चेक कर सकते हैं कि आपका रिजल्ट आया कि नहीं, ठीक है। सिमिलरली हम जैसे कि ये प्रॉब्लम हमने दिया, दूसरे प्रॉब्लम को आप क्रॉस चेक करिए कि रिजल्ट आपके वही है कि नहीं। राइट डाउन द कोड। तो दिस इज द ऑल अबाउट द लैपलास ट्रांसफॉर्म। There are various application of Laplace transform you have studied. This is one more method to find out the Laplace transform in the inverse partial fraction method. This is simplest way to find out the Laplace transform by using the direct built-in command. You have studied the Laplace transform, inverse Laplace transform by using partial fraction expansion methods. You have also studied in the mathematics class to find out the inverse Laplace transform by using partial fraction expansion methods. This is the basic principle to find out the Laplace transform. Simply तो सिंपली आप यहां पे हियर दिस इज द न्यूमरेटर या NUM न्यूमरेटर एंड दिस इज DEM डिनोमिनेटर। न्यूमरेटर एंड डिनोमिनेटर को हम कैसे लिखेंगे मैटलैब में? ये मेन पर्पज है, मेन आपका ये न्यूमरेटर को डिक्लेयर करने आ गया और डिनोमिनेटर को। फिर उसके बाद तो वन लाइन कोड है कि आपको न्यूमरेटर इनपुट्स जो आपका पॉलिनोमियल टर्म में है उसको आप लिख लीजिए और डिनोमिनेटर्स को उसको डिक्लेयर कर दीजिए, डिस्प्ले करा दीजिए, ठीक है। और उसमें जो बिल्ट इन कमांड है कि आपका रेसिड्यू, उसमें बिल्ट इन कमांड है, रेसिड्यू कर देंगे तो आपके कोफिशिएंट न्यूमरेटर डिनोमिनेटर जो है उसका पार्शियल फ्रैक्शन निकाल के दे देगा, ठीक है। तो आपका मींस RP के कोफिशिएंट की वैल्यू आ जाएगी। तो ये दीज आर द बिल्ट इन फंक्शन, और फिर उसको फिर सिस्टम के फॉर्म में वो कन्वर्ट कर देगा, पोल्स और जीरोस की आपकी वैल्यूज दे देगा। तो आपका जैसे कि आपका जो लैप्लास ट्रांसफॉर्म S signifies the real and imaginary term, sigma plus j omega. The Laplace transform signifies the real and imaginary term. तो simply आपका next program to write down the program to generate partial fraction expansion in the Laplace transform. Simply you have write down the basic code to NUM. Simply you have write down the first of all you write the CLC code, clear the window, CLC and clear all. The basic previous codes can be clear all and CLC. Then you have write down the declaration. First you have write down the NUM signifies the numerator. This is the NUM means the numerator polynomial. Given the numerator input enter the numerator variables, enter the numerator coefficients, coefficients, ठीक. Then you have enter declare the 1 1 1 1 1 1 1 1 in bracket, and then declare the denominator coefficient. Then means the suppose this is x plus 1, this type of function can be written. You have write down the coefficient of numerator. The value of numerator coefficient is written as numerator is equal to denominator coefficient. Enter the denominator coefficient. Denominator coefficient. Then your parenthesis, your then right cross write the denominator. Command window can be expanded. You have delete this bracket, extra bracket. Enter the denominator and then parenthesis is semicolon. Enter the denominator coefficient is written bracket 1464 space 146. Then write the RPK RPK. This is the poles, zeros, locations can be found by the partial fraction expansion method. You have written the residue. Residue is the method. Residue, you have written residue in this small. RES. RPK suffix can be written with R, small p, and small k. This is the case sensitive. The alphabets are the case sensitive. Commands are case sensitive. You have written in the small letters, and you have declared the NUM. This is signifies the numerator, and DUDN. This signifies the denominator. Enter. Display. You have write the command this means you have chosen this. Display the value. DSP is the display DS residue in the partial fraction. Bracket is closed. Enter. And you have write the DSPR. DSPR means you have displayed the real R. Enter. This is the result. This is the R values can be displayed, and similarly you have displayed the P suffix for the pole, R suffix for the zeros. Pole. DSP. R suffix for the residue. This is the term. You have given the complex terms. real plus complex, imaginary. Because the S signifies the real plus imaginary term. Sigma plus j omega. The residue term here is real plus imaginary. And you have displayed the only poles term, then DSPP gives the pole. Here, this is the pole of the system. ठीक. This is all about partial fraction by using partial fraction to find out the inverse Laplace transform of given function. This is the partial fraction method to find the inverse Laplace transform. This is the simplest way to find out the inverse transform of the given system by partial fraction expansion method. Simply find out the partial fraction by in mathematics class. Simply find out the coefficient a1, a2, a3 and solve it. Coefficient of a1, a2 and 3 and then you put it and you find the inverse Laplace transform of the given expansion. Then similarly you have used the MATLAB code to find out the inverse Laplace transform of the given function. These are the steps, basic steps. Simply 3 or 4 line codes. The basic code is 4 or 5 lines, and all basic declaration you have. First of all, you have enter the input. You have write the numerator variables, numerators, polynomial, coefficients, and then you display the denominator, enter the denominator, then you have then given the residue command to find out the real and the pole and to display the values. This is all about the inverse Laplace transform of a given function. Then you have in next lab you have find out the Fourier transform and jet transform. In your syllabus, the various transform you have studied the Laplace transform for the continuous time signal. You have studied the jet transform for discrete time system. Discrete time signals के लिए हम jet transform use करते हैं और Laplace transform for the continuous time signals. In the next class, we will study the code to write a given signal, the jet transform and the Fourier transform. That's all.